In this video, we're going to take a look at our third scenario, factoring binomials. So again, recall that binomial means that we have two terms. So all the techniques that we're going to look at in this video are specific to when the polynomial has exactly two terms. And there's a lot of form recognition here. So let's get started. This first one is pretty easy to factor, but you have to recognize this. This is what's called a difference, because it's subtraction, of squares. A squared minus b squared. That is to say 4x. 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. And 25 is a perfect square, 5 times 5. And that is, according to our special forms that we learned when we were multiplying out polynomials, always factors as a plus b times a minus b, where in this particular case, a is the square root of the first term and b is the square root of the second term. So if a squared is equal to 4x squared, then a is equal to 2x. And if b is equal to b squared is equal to 25, then b is equal to 5. So how does this factor? It factors as simply 2x plus 5 times 2x minus 5. It is the difference of squares. This next term, or example, is a little bit different. It's not a difference of squares. It's a sum, and they have no GCF. So this is a sum with no GCF, a binomial sum with no GCF. That is to say 2 and 5 don't have anything in common that I can readily factor out. There are no whole numbers that divide into 2 and 5 evenly. Their GCF is 1. And they don't have any powers of x in common. That is to say there is no factoring to be done here. This is what we call a prime polynomial, or this polynomial is prime polynomial. Just like when you can't factor a number, right? Oh, prime, same idea. Okay. The next two are very special forms, and we haven't talked about these special forms yet. So these may be sort of foreign to a lot of people that don't remember doing this in Math 123 or the equivalent. This is what's called a sum of cubes, because it is x cubed plus 8's a perfect cube. It's 2 times 2 times 2. So that's x cubed plus 2 cubed. And this is a difference of cubes. That is to say, this is 3y cubed, because 3 times 3 times 3 is 27, and y times y times y is y cubed, minus, well, 1 is just 1 cubed by default there. So it's still a difference of cubes. Now, in each one of these scenarios, there is a special factoring form. And it's just going to require some rote memorization on your guys' part. You're just going to have to memorize these. So the sooner you make flashcards or something for them, the better. The sum of cubes, a cubed plus b cubed, factors in the following form: a, b, a squared, ab, b squared. So that's our general format. And we have a special acronym that sometimes is taught with this. It's the acronym SOAP, which is an acronym for the signs. This is the same, this is opposite, and this is always positive. And it's referring to whatever this sign is. So if this sign is positive, this sign is the same. If this sign is positive, this sign is opposite, and this one's always positive no matter what. And that's actually true for both the sum of cubes and the difference of cubes. That SOAP acronym. So let's see how this factors here. From our decomposition here, we can see that if we are matching these two forms up, A is played by the role of x, and B is played by the role of 2. So if A cubed plus B cubed factors as A, same sign B, A squared, AB, B, opposite sign, always positive. Sorry, that's a B squared. Then we can just plug and chug. That is to say, x cubed plus 2 cubed factors as x plus 2, x squared minus x times 2 plus 2 squared. And we can clean that up a little bit. And we get x plus 2 times x squared minus 2x plus 4. And that's how this factors. Now, in a similar manner, up here for the difference of cubes, we have A cubed minus B cubed. And that's going to have that same format. A, B, A squared, AB, B squared. That's the format you want to memorize. And then same acronym in terms of our signs here. This is going to be the same, opposite, always positive acronym. And so since this guy started out negative, this will be negative, opposite, always positive. And in this case, A is 3y and B is the number 1. So what was 27y cubed minus 1, which we rewrote as 3y cubed minus 1 cubed, factors as 3y and 1, 3y squared, 3y times 1, and 1 squared, where the signs are the same, opposite, and always positive. Cleaning this up, we get 3y minus 1. 3y squared quantity is a 9y squared, so the quantity 3y times 3y is 9y squared, plus 3y plus 1. And that is our factored form for this elusive sum and difference of squares. So just to recap here, you can memorize the same formula for both of these. If you have A cubed and B cubed, and your signs are either positive or negative, depending, it will always factor as A, B, in parentheses, and then A squared, AB, B squared. And the acronym is, again, same, opposite, always positive, SOAP. And so if this guy is positive, if this first is positive, then in the parentheses it'll be positive. If it's negative, it'll be negative. So I'll just write plus or minus there. So whatever you start out with, that's what ends up as the sign in between A and B. And then because this one's opposite, I'm going to write it as minus plus instead of plus minus, and then always positive. So these were the same, these were opposite, and this was always positive. And that's the SOAP acronym for factoring sums and differences of cubes. And that's how you factor a bunch of different types of binomials.